Olá pessoal, sejam bem-vindos a mais um episódio aqui da série Aprendendo, Ciência da Comigo. E hoje, continuando aqui a série do canal do Engenharia, Building Science 201, vamos para o episódio 2 da segunda temporada ali. O título do vídeo é Gestão da Água, e agora a parte de mitigação. No primeiro episódio a gente viu sobre a parte de proteção em relação à água. Bora lá.
All right, friends, welcome back to Build Science 201. We're in the water control right now, and we are talking mitigation today, right, Steve?
That is correct.
We got a lot of good stuff today. Build Science 201, water mitigation. Let's get going.
Build Science 201 is sponsored by Anderson Windows and Doors, Huber Engineered Woods, and Proseco.
Hey guys, I'm Matt Reisinger, and today we're diving into an essential topic for any construction project, sequencing and trades coordination. Do you know that most failures occur when the trades aren't aligned? And this is especially true at critical trees. Yep, that's just the build. Where do we start here? Guys, I appreciate Proseco for sponsoring it. Thanks for watching. All right, Steve, mitigation. So where do we start here? Last time we talked about getting water off the building, but what happens when water touches the building?
Well, any water that we can't get rid of via protection, then we have to deal with.
Yep.
And so basically I tell everybody we need to provide a path. And that's what mitigation is. Give it a path, right? We call it water management.
Yep.
We don't call it water barrier, water stop. You know, those names exist, but we call it water management for a reason.
One of my favorite quotes from David Nicastro, a famous building scientist, is it's not about keeping water out, it's about letting water out. And another one of his quotes that I think fits here is, if it can't dry, it's going to die. And with that being said, Steve, I've got some photos of a house that I remodeled a couple years ago. The client called me and said, hey, Matt, these windows in the back of my house are exhibiting some signs of rot. This is literally only a 20-year-old house. I think it was maybe 19 years old at this time, so not very old. So I went over and I checked out the house, and of course I brought one of my best rot detection devices with me, which is my knife, and I poked around on these windows here on the first floor to see what was happening. But before we go to the next slide, I want to mention, pretty traditional house. You know, we had overhangs here, like 2-foot overhangs. There was one big mistake made in that in this corner where the roof meets the wall, you can see there's kind of a gutter dam there so water wouldn't overflow the gutter. But what was missing was something called a kick-out flashing. That's where if there's water running down the wall, it gets kicked out from the wall so that we can't get water in between basically the roof and the wall intersection. So a kick-out flashing was missing. And you also notice this is a pretty tall 2-story portion of the house with a 2-foot overhang. So you might guess that these windows at the bottom down here are getting a fair amount of water on them over time. So with that being said, let's see what we found.
Well, before we jump ahead, because I'm going to talk a little bit different about what I saw in this, and this comes into that whole, you know, when we talked about protection, risk assessment, the same with mitigation, we have to understand what our risk is. So, you know, Matt talked about this. We're putting that in a corner right by the window, water coming down here creates a problem.
Yep.
But where's that water come from? Look at this. You have all of this gutter.
Yep.
All that gutter goes into a downspout and kicks out onto the roof there.
I didn't even notice that.
So it's not this roof that's the problem. It's the main house roof that's contributing. And then you have this inside corner that I don't really see a cricket in there. And so all of that water is coming down into that corner. And so that assessment of what do I do with all of this water that's now coming down into that corner?
Let's peel back the skin and see what we found over here. Okay, so on the left, you can see that we found some rot. That was pretty obvious. But when we took the stucco off, Steve, that's where things look bad. So this right-hand corner you're seeing there, that's right below where that missing kick-out flashing was and where that roof was intersecting. And the builder at the time had used a house wrap, so we had some type of raincoat on underneath. But what happened was water was getting back there and it had no pathway to get out. And as a result, this house, less than 20 years old, you can see that the sheathing, which happened to be ornate strand board, just absolutely destroyed. And even the standard studs in that wall, totally destroyed.
Yeah, and you know, when I remodel projects and do remodeling projects, one of the things I love to go in, even if we're demoing a house, I like to get in there the day or two before we demo and take it apart, because you can learn a lot. Look at this. You can see here, look at that heavy rot.
Yep.
In that area. It gets a little lighter, and then there's almost nothing up there. It's that suggestion that that water is coming down, and the minute I don't have a path for it, it stops and rots.
Yeah, that's right. Great point. Okay, so now I thought on the right-hand side I'd actually show you what that looks like on the inside. So when we have sitting water against wood materials, remember we said earlier, if it can't dry, it's going to die. That's where the issues come in. That wood is going to break down if it can't dry. Now wood, when it's out in the forest, a living tree, it's soaking up the water, it's doing fine. When the tree dies and falls over, it rots over time. And part of that rot, or most of that rot, happens because water sits on those logs and it rots over time. On the other hand, your dining room table that's inside your house here, is going to be just fine decades and decades, maybe even centuries from now, because it's dry and it's kept dry. And if it gets wet, if I spill my water bottle here, it has nothing preventing that drying. On the other hand, this house, water got in behind that house wrap. There was no pathway for that water to get out. This is a modern house built to modern codes with insulation in there. There's no easy way for that wood to dry. So now that moisture accumulates and accumulates, and the wood broke down and had actual wet rot. On the inside, the paper facing of the drywall started to accumulate some microbial growth. It was a mess all around, Steve.
Yeah, and
Meu sonho é ser a gente conseguisse umas casas assim, claro que sempre quando tem uma situação assim, problema grande, o proprietário da casa tá nervoso, né, com a situação. A gente, assim, que quer preocupar com os detalhes da construção, a gente tiver a oportunidade de ver, de conhecer casas assim, né, de estudar, né, que acaba que a gente vai estudar ali os problemas, que tipo de problema, conseguir analisar ali, nossa, poderia ter feito isso, ou concretizar uma hipótese de fazer algo de determinada maneira, né, poderia não ter acontecido esse problema, e não só de ficar lá julgando, né, porque aquele negócio, né, ser engenheiro de obra pronta é fácil, né, estar ali no dia a dia ou no antes e tentar resolver o problema, como é nossa luta diária aqui, né, porque nem sempre é fácil simplesmente ter esse determinado posicionamento, fazer determinadas coisas. O que a gente vai aprendendo aqui é que, às vezes, para fazer o direito tem um custo, né, e nem querem fazer o custo, porque outras estão fazendo com custos menores, e às vezes o problema demora para acontecer, né, então, aquele negócio, né. A gente que está aqui estudando sobre ciência da construção, o nosso preço é prolongar se acontecer algum problema, né, ter mais controle se acontecer. Para outras pessoas jogam de simplesmente o da sorte, né, pode ser. Essa é intencional aqui. E aí esse mitigação, né, eles dão outro exemplo, né, sobre também poder chamar de gerenciamento de água, né, que mitigar a gente dá um caminho para a água. No primeiro a gente entendeu a importância de dar o máximo de proteções para possíveis locais de entrada de água, locais de incidência de água direto, uma fachada, uma parede de uma fachada, uma esquadria. A importância da gente proteger ao máximo materiais. A gente ter uma fachada com uma maior durabilidade, uma esquadria mais estanque. E que se a gente não fizer isso, a gente tem que investir em materiais melhores ali para conseguir proteger minimamente tanto a fachada quanto as esquadrias. E aí um outro ponto, uma frase importante aqui, se a gente não conseguir secar, vai morrer. Então se uma parede está entrando água, se tem problema ali dela que está entrando água, também essa parede vai morrer, vai ter problemas. Parei nessa imagem, é bem legal, né, para quem a galera aí, os marketing fácil da internet de que casa de steel frame não mofa, não sei o que, confiam na membrana hidrófuga milagrosa, né, de que só botar uma membrana ali a casa não vai mofar. Esse negócio, a gente é intencional, a partir do momento que a gente coloca de qualquer jeito, infelizmente a gente está suscetível sim também a ter uma casa como
the thing that I see here is, notice, we do have some flashing, right? So the builder could very easily say, hey, flashing box, I checked it, homeowner, we got flashing up there. Hey, Mr. Building Inspector, Mrs. Building Inspector, we did proper flashing at this window. The thing they didn't provide was a path for that water to go. Yep. And if you don't provide a path, Mother Nature will.
One of the big ways that we're going to prevent that is by...
Aí, então, um detalhe importante, né? Às vezes a gente cria checklists, né? Isso. Algumas coisas ficam até automáticas, né? Mas se a gente não tivesse a intenção de criar um caminho para a água, igual ele falou ali, a natureza cuida desse caminho, nem sempre é favorável, né, para a própria população.
By giving a pathway for the water. This is what we commonly refer to as a rain screen. This is actually my house. You're looking at the back of my house under construction. The silver facing you're seeing there is my exterior insulation that I used in my house. And behind that is my raincoat. I use zip system sheathing in my house. That's my water and air barrier in the house. I added the insulation, but I wanted to make sure there was a pathway for any water that got past my cladding to be able to get out, to drain and dry, to make sure that I didn't have problems. So you can see there, one of my frame carpenters installing my siding, he's nailing it onto that 1x4 that's been screwed into the structure of my house. And now we've got this air gap. You could literally put your hand in that gap right there.
Yeah, he's doing it.
To the right. That's right. He's holding his hand on that siding and nailing that siding on so that now that siding is in a spot that water gets past the siding we've got no problems. It'll be able to drain out of that space, no problem. And then there's a pathway at the top and the bottom for air to flow into there, and that's commonly referred to as a rain screen. Let's go back to climate for a second, Steve. I've heard several smart building scientists say that if you're in an area that gets 20 inches or more of rain a year, you really should use a rain screen. That's enough water that you really should do it on every project in every location. If you're in a really dry climate where you have less than 20, you're building in the desert, you're building in LA, some of these climates that get maybe 12 or 15 inches of rain, maybe not as necessary, but anybody who's above 20, you really need a rain screen on all your claddings.
Yeah, and one of the things I wanted to point out, if you haven't seen 101 or 201 protection, go check it out. Check this out, right? Window protected, door, window, all windows, all windows. An excellent job at window protection.
Yep. By the way, you helped me on the house, Steve, so we talked about that together.
We talked about rain screen. This is a project of mine, very similar to yours, where we use the wood furring. This is what I would call a closed joint system. It's lap.
Isso é legal, que eu estava pensando que estava trabalhando com outro projeto que tela de chuva, que eles lá agora têm um material exatamente para fazer essa tela. Pode fazer simplesmente, no caso eles usam a madeira ali, talvez a gente poderia usar um perfil cartola, talvez um perfil cartola seja mais ideal, né? Para fazer esse afastamento da parede e criar esse caminho para a água ali da membrana. Solução. E aí deixar a água acumular. Pega aquele negócio, assim, depois de fazer um teste em casa, você pressionar uma placa em cima da membrana direto, qualquer água que entra, se a membrana não for totalmente permeável, faça esse teste. Tem membrana no mercado que a água atravessa, principalmente quando ela está pressionada assim. Então faz bastante diferença para a durabilidade da casa.
Siding, there's no air, not intentionally going into that. So it is about drying. The 3/4 inch space there also does provide some drying up through. It just can't dry through the cladding.
Right, makes sense.
As opposed to, this is a project where we did open joint, and you can see it there. That's a 3/16 inch open joint. So those are basically just sticks sitting on top of the wall.
So in other words, they're stacked rather than lapped.
Exactly. So yes, water can get in there, but so can air, and water can get out. So we can dry it. So it's all about that rate question, right?
What you're seeing here is that there's a rain screen back here, and then Steve and the builder used some tar paper to drape in there. So really you'd have a black space behind there. But what you can't tell quite super well on this photo is that there's actually an air gap in there.
You want to bring that up a little.
There you go.
You can see what Matt's talking about.
You can put your hand back there.
This is really shaped like that.
Yep, it's U-shaped back there. So there is a rain screen gap behind that siding. As a side note, there are places in the United States currently and Canada where rain screens are code. If you're building in the Pacific Northwest, there's lots of jurisdictions, Vancouver, British Columbia, other places where you have to do a rain screen. Lots of places like where I build, it's not code, but it's definitely best practice.
This is a project, this is up in Colorado, Steamboat Springs area. And the reason why I threw this up there is just multiple materials, right? We have metal, we have lap siding, and here we have a series of vertical siding. So it doesn't really matter what kind of siding you're using. Water doesn't have a preference. Like, hey, I'm only going to rot buildings that are stucco, or I'm only going to rot buildings that are lap siding.
Right.
No, water doesn't care. So we have to provide a path here. We have to provide a path here. Notice that our cap flashing there over the metal, the furring goes behind it. So that water can continue down, and we're dealing with it down at the bottom of the wall.
Smart.
So this is a photo that's dealing with mitigation, but it pretty much doesn't have to do with the building. That first photo you showed when I talked about roof rainwater, this is all piping dedicated to rainwater.
Ah, so that's your downspouts and your gutters piping away from the house.
These will all eventually get cut somewhere up in here, and then they'll get fixed to the downspout, and this goes down, and then this goes to daylight somewhere down a little ways off the hill.
So instead of a footing drain that would have a perforated pipe, that's all solid pipe.
Yep.
So that now it's taking all that water from your roof into your gutter system and then piping that out to a lowered section on the property.
Right, and notice it's just above the footing, which is down below there. So we have our footing drain is in there just below. So as they're backfilling that excavation, they're now putting in this second level of mitigation that's dealing with roof rainwater. This is this kind of the same concept. This is that house that had the open joint rain screen. This is what I call a ground gutter. So we basically, the homeowners didn't want the gutters to be on the building. So we center this ground gutter on the drip line. The water drips, it goes through stone into this perforated pipe. And in this jurisdiction, we have to take care of all of our rainwater on site. So we have an on site kind of percolating reservoir that this goes down to in the low ground. But the idea that, you know, my buddy George there, the excavator, just does an impeccable job of basically putting the gutter in the ground.
I like that. That's smart.
And then this one here, notice there's some little holes there. Those are actually laterals that go through the foundation. Now it's funny because some people will argue, why do you want to connect the inside or the outside? Well, when you think about what that footing drain does, for me, I'm more concerned about the water that's rising up than the water that's coming down.
That's right.
And so as it rises up, I want to make sure that I can capture that in a nice level fashion. And we have a pipe on the inside of the footing and one on the outside of the footing to get rid of it.
And then ultimately, if that's a below grade foundation, there's going to be a sump pump down there and maybe even a backup sump pump, which is the lowest point in the foundation.
Right.
All that water gathers in one spot and we pump it outside.
Right. And as far as mitigation, if we are talking groundwater, understand this is our waterproofing. This is a drainage mat.
So the light gray you're seeing here, Steve, that's the waterproofing. And then the kind of blackish material there is what we call a dimple mat. We use those in all kinds of places, but below grade's really smart. It kind of looks like an egg crate material. And the egg crate is up against the foundation that kind of nipples on the crate. And then there's a filter fabric on top of that so that any water that comes up against that foundation is going to find basically an airspace, an air gap, a rain screen space. And the filter fabric is going to keep that from getting clogged by soil. That's what they call a filtered fabric. And then that's going to be able to drop down in a sheet to our drain below that can ultimately be dealt with a pump or with gravity.
And what I think is really cool, this is the polyguard system. And I drew that line there. Notice this 2-foot section, the dimple mat here is probably 2x the size of the dimple mat up there.
Cool.
So they understand that as I accumulate water down here, I have to deal with it with a larger mat.
Smart.
Yeah, so this is groundwater gone bad. So there's a really close-up picture. And the saddest thing about this is, well, first of all, the homeowner had to pay for about a 300 linear foot excavation that was 14 feet deep, 10 foot wide on a house that was about 3 years old.
That was expensive.
Very expensive. And when we got down there, this is what we found. And the sad thing about this, Matt, is, you know, it has the perforated pipe, it had the filter fabric, and it actually had some stones. The problem was the installation was like somebody kicked it in to the hole. It wasn't installed properly. And this is probably one of at least a dozen cuts that I've made. It was filled solid.
Yikes.
It was just bad execution. So, you know, there's checking the box and there's checking the box, right? Checking the box to say, yeah, I did it. Checking the box that said I did it and I did it right.
Yeah.
Essa é a parte difícil de lidar com obra, né? Às vezes a gente tá ali selecionando o material correto, pensa ali na execução correta, passa para o pessoal, mas nem sempre consegue estar ali exatamente no momento da execução. E um serviço assim de escavação, escava ali, volta, às vezes a máquina já está ali, já tampa ao mesmo tempo, o cara manda uma foto ali, mais ou menos, você diz que está ok, que você vê ali os materiais que você pensou para utilizar, então a parte do controle e fiscalização para fazer obras com esse detalhe também é muito importante.
Steve, I think one of our big takeaways here for that young builder in the audience is we really need to think about that pathway for that water to come out. It's not about caulking things in, it's about making sure that we've got a path for that water to get out.
Yeah, and you know, you talk about young builders, but I encourage...
Só comentando ali, até aquele equipamento ali, aquele material ali com as covinhas que eles falaram, fui conhecer recentemente, eu também não conheço. Chamam de isoestude, tem outros nomes também. E é realmente bastante interessante. Você faz uma parede de muro de arrimo, também vai ter uma chegada de água ali. E antes de chegar na impermeabilização, você tem essa camada desse material ali que já vai drenar, vai ajudar a drenar a água ali, cria aquele espaço de drenagem. Indo, dreno na parte de baixo, organizar também para fazer a mitigação dessa água. Antes de acontecer problema nessa arrimo, parede de contenção também é muito pequena.
Homeowners, you know, when you're working with your builder, when you're working with your architect, to ask the simple questions. Hey, where does the water go in this design?
It's a great point.
And it's like, well, if the architect sits there and says, oh, well, I have protection here, we have a covered overhang, that still doesn't solve for if water gets in. You know, one of my biggest questions is anytime you put sealant, caulking, some type of closure on a building, the question isn't necessarily what you're sealing out. The question is, what am I sealing in?
Yeah.
Right? Because that's when you investigate. When I've investigated buildings, it's not because they were successful at keeping stuff out.
That's right.
They were unsuccessful.
It's always going to be unsuccessful keeping it out.
So that brings us, you know, to a really good photo here. We talked about protection in the first video, which is good, but that doesn't mean you're not going to get some rainwater coming into there. So how do we deal with that? Just like we did our vertical rain screen here, and in this case it's horizontal because it's an open joint rain screen, we have our rain screen system here. So this is basically built like a shower in here. And this
so there's living space below that, or there's foundation below that?
This is Carl's workshops down below that.
Okay, gotcha.
Right? So we're dealing with that water there. And like I said, this is an open joint rain screen there. So we have horizontal members there that have our drainable capacity.
And I'd like to point out, if you don't have the capacity to do that, the way to mitigate that is to not put living space below. Have a jog in your foundation and just make that dirt below, basically, so you don't have to worry about it. Whereas Steve, by spending the time, and the builder, I think that's Howell Custom Homes, doing a really good job, they're able to capture that square footage below and turn that into living space.
Yeah, and you can see we have stone here where we switched materials. Notice at that material switch, our rain screen system went to this MTI dry, which is a drainable rain screen underneath the lath. So making that connection there allows water to move, and then that MTI dry connects to the footing drain.
It's a great example of that negative porch.
And then these are just some more mitigations. These are at the window, so you can see the window shelf, it drains right into that rain screen system. And one of the things here that you have to pay attention to with your windows, it's hard to see, but I'll highlight it there, that is the weep hole that is draining water from internally in the window. If water gets into that window frame between the sash and the frame, it needs to be able to get out. So good window manufacturers create weeps and provide the same mitigation. We need to pick it up from there and continue the path of mitigation. All right, so continuing on with just little elements, here we have that kick-out flashing. This is water that comes down the roof. Rather than continuing down the wall, it gets rerouted into our gutter.
At the top of our presentation, that was missing on that house, which caused all those problems by getting the sheathing wet and rotting all that stuff down below. So that's a great example, is that kick-out flashing photo there.
And in New England, we're no smarter than you guys in Austin, because we have the same problem. That water comes down, you can see all of the water staining here. And look at this, the electric meter's right there, and it's all black and dirt on the top of it.
That kick-out flash was missing. That's a critical component on houses.
And this is just continuing on to it.
That kick-out flash was missing.
Um print aqui. Acontece. A gente vai olhar para cá, a gente fica reparando nas casas, e isso acontece bastante. Nos locais a gente vê que não tem essa proteção na quina, em telhado que está chegando assim. E aí a água simplesmente desce dessa forma, e todo preto assim.
That's a critical component on houses.
And this is just continuing on to the smallest of details. Now, you've been to this house. This is a farmhouse up by Gloucester, where we did a deck. We hung it off the outside. Notice we have all of these wooden joists. The wooden joists are set in these little steel hangers that were fabricated by the steel guy. So the question again, where does the water go? Well, if water gets in here, we don't want our joist sitting in it and rotting, like your DeCastro friend. Right, so it sits on a little neoprene piece here, so water can drain out there, but we also cut the back side of that joist hanger,
that's really
so
smart.
Water can drain out of there. So these joists are never sitting in any kind of water.
That's
even
really
if it's
smart.
raining, water just goes right by them.
That's great.
And then lastly, I mean, these are just a few examples of rain screen systems.
Yeah, there's all kinds of different options. We showed a lot of 1x4s, let's say, in a bunch of our photos, including my house. This one in particular is an interesting one because this one's intended for a stucco install. So it's a dimple mat on one side and a filter fabric on the other, kind of like what we showed.
Isso, então pode utilizar na parede. Porque aqui no Brasil, estão utilizando, fazendo a fachada com pedra, né? Daí, na fachada com pedra, essa drenagem atrás é bastante perigoso para acumular água na parede. É importante ter uma drenagem depois dessas pedras.
Showed on a foundation. And then there's a bunch of different 3D mesh options out there in the marketplace. And that bottom right photo you're seeing there, that's a black plastic that kind of forms a dimple. And you can get them in various thicknesses because there's a lot of issues sometimes with adding thickness to our cladding and dealing with windows, that sort of thing. So what we're trying to show here is that there's different options. And again, I want you guys to think about climate zone and where you're building. The more risk you have with your architecture, with your lack thereof or your addition of overhangs, that's where this mitigation really comes into play on our buildings. And we need to think ahead about this. If we don't think about it, Mother Nature will take care of it for us.
Yeah, and it's not that hard. I mean, we spend literally millions of dollars correcting failures every year because we didn't ask the question of where does the water go?
That's right. Stay tuned. We've got one more module here on water management.
Prevention. And prevention is where we say stop here. That is where we pick our fight with Mother Nature. Now, mitigation is to limit the amount of fighting we have to do, but at some point we have to put up a fight, and that's what we're going to talk about.
All right, guys, Build Science 201. See you next time on The Build Show.
E como ele finalizou ali, né? A gente tem que saber onde a gente vai construir, qual a zona biomática, das características ali da região para projetar corretamente, para entender corretamente como que vai, de acordo com o projeto também, entender qual vai ser a necessidade desse projeto. Água. Por isso que pode simplesmente sair vomitando, palavra, né? Vomitando o projeto, né? Querem que o projeto seja feito do dia para a noite, né? É praticamente impossível você fazer coisas assim de qualquer forma, porque senão você não consegue resolver esse tipo de coisa. Só ter uma imagem de arquitetura bonita e preencher de materiais ali, não fechar nesses detalhes, né? Valor muito alto, como ele falou ali, a resolver também vai ser valores muito altos, né? Uma afetação à fachada, afetação à parede, aí tem que ter parede. Quanto mais a gente puder evitar isso antes, pensando e planejando, com certeza vai ser melhor. Se você tenha gostado, deixa nos comentários o que você achou sobre esse episódio de mitigação de água. Um abraço e até o próximo vídeo.